Hi, welcome everyone. My name is Say, and my project is called Fashion Image Recommender, where I am comparing a basic CNN model trained with in-house dataset to a pre-trained model with a much larger, complex, and general-purpose dataset. For the last few years, I've been a product manager in e-commerce for various types of fashion brands, and optimizing recommender system has been one of the biggest challenges for me. Most of the recommendation systems still rely heavily on text-based tabular data, which involves extensive tagging and data entry. Here, I'm using the fashion product images dataset from Kaggle. The data is comprised of 5,000 professionally shot product images and multiple label attributes, including master category, subcategory, article type, base color, season, and etc. For the initial part of my project, I used article types as the label for the training the model, which had 141 unique classes. There are three parts to a recommender system. 1, candidate generation. 2, scoring. 3, ranking. So here I decided to build a CNN model for the basic recommendation system using TensorFlow. A convolutional neural network is a deep learning algorithm which can take an image input, assign importance to various aspects and objects in the image, and be able to differentiate one from the other. So I spun this up on AWS EC2 instance using deep learning AMI. And after 150 epochs of training, I got a model that classifies images from our dataset into 141 unique classes with roughly 80% accuracy. This model was used to classify an image and create a list of products in the same class. Then the recommender function calculates similarities with all the other images in the list and ranks them. Here I used Euclidean distance to calculate the similarities. This recommender system worked fine as far as finding other items that belong to the same category and calculating the similarities from the model. But I realized the labels that we're using in the training process of the model had its own limitations. Customers, especially in fashion, aren't always looking to purchase things in the same category as what they're viewing at the moment. There has to be a bridge that connects the user from one section of the product catalog to another to keep them interested. So I tried using pre-trained model that wasn't trained on our own data set for recommender system. ResNet50 is a very complex CNN model that had high accuracy on ImageNet database, which holds approximately 1.28 million images in 1,000 categories. The secret sauce of deep neural network is the rich feature engineering done in the layer before the classifier. You can think of this learned data representation as an embedding. Essentially, this model has learned to take an image and represent that image as a set of numbers. Here, we're generating our image embedding using ResNet50, which returns 2048 weights in a high-dimensional space. Using the image embeddings from ResNet50, I made a recommender system that directly calculated cosine similarities amongst items in the dataset. By doing so, the recommender system is no longer bound by the labels used in our dataset. This approach is actually closer to an unsupervised learning compared to the previous model, which I built using CNN. The graph you see on the slide is the TSNE representation of the embeddings. As you can see, there are a bit more variations in the recommended systems, recommended items. For the belt, the recommended items include a shoe that has similar braided style as the original belt. For the women's undergarment, the recommendation includes casual and ethnic dresses as well as nightgowns. Overall, it demonstrates how complex pre-trained model can be used in recommendation system without companies and brands investing time, effort, and computational power. In the future, I'd like to explore developing a model using natural language processing of the product descriptions and combine the use of both text-based model and the image-based model. Then I'd like to try using GAN, where it takes text as an input and outputs images based on its learnings. If you're interested in learning more about my project, myself, or as a potential employee, feel free to reach out via links shared on the slide. Thank you.